This is our last section in Unit B, our notes for B-6. I can prove and apply theorems about angles. We want to start building your arsenal of reasons for your two-column proofs, the reasons you will use in those proofs. So I'm going to give you some here. You might want to put these in your notes. It would be nice to have these in one location, so you just kind of go back and sort of look through the list and see what you can use for your reasons when you're doing your proofs. And these are kind of good ones these are some basic ones that you should know. So first of all, vertical angles are congruent. And so you can write as a reason, vertical angles are congruent. When you see two vertical angles, you know that the angles have to be congruent. You can write that down. The congruent supplements theorem says if two angles are supplements of the same angle, then the two angles are congruent. If two angles are complements of the same angle, then the two angles are congruent. Here's an easy one that people forget about all the time. All right angles are congruent. You see two right angles in a problem, you can simply say they're congruent because all right angles are congruent. If two angles are both congruent and supplementary, then each angle is a right angle. Think about it. If they're both congruent and they're supplementary, the two angles have to add to 180. They both have to be the same number. They both have to be 90. So each angle is a right angle. So there's some reasons that you want to use in some proofs down the line, as well as some of the ones that we were using in the last section from our algebraic properties. Although we aren't really using algebraic properties as we get farther into this course, because this is a geometry course, we won't be using algebraic reasons for most of the things we do. We'll be using geometric reasons. We'll be using these sorts of statements, these sort of theorems, and that thing. All right, so let's take a look at a couple of proofs, writing a two-column proof. Let's kind of go through this proof, and then I'll take a look at a paragraph proof as well. So I want to write a two-column proof. So first of all, it says given angle 1 is congruent to angle 4. So angle 1 and angle 4 are congruent. We want to prove that angle 2 is congruent to angle 3. We want to show that angle 2 and angle 3 are congruent. So a lot of times what I will do is we start off with the given information. So again, it's a two-column proof. So we'll have a column over here with all the statements, a column over here with all the reasons. The first thing I will do is I will put in the given information. Angle 1 is congruent to angle 4. Why? Why is it? It's given. And by the way, you don't have to number your statements and reasons if you don't want to. You could just start off with that information like that. So, this is just something you could say. All right, so from here, what's going to happen? You have to think about what can I say next that will show that angle 2 and angle 3 are congruent. Well, the first thing I notice is that angle 4 and angle 2 are vertical angles. And so I can write angle 4 is congruent to angle 2. Now, how do I know that? Well, I know angle 4 and angle 2 are congruent because all vertical angles are congruent. So that would be my reason. You could probably also say the same thing about 1 and 3, but we're not using that property. Instead, we're going to say angle 1 is congruent to angle 2. So how do I know angle 1 is congruent to angle 2? It's what we call the transitive property, and it's from these algebraic concepts, the transitive property, meaning that if, we have one angle is congruent to another angle, and then that angle again is congruent to a third angle, then A and C, in this case, would also have to be congruent. It's kind of like the law of syllogism. It's kind of like saying that chain rule. And so we're saying if angle 1 is congruent to angle 4 and angle 2 is congruent to angle 4, then it makes sense that angle 1 and angle 2 have to be congruent. And that's the transitive property of congruence. And so that would be the reason you would use. Step 4 rather. Again, here we go. Angle 1 and angle 3 are vertical angles. So they have to be congruent. Angle 1 and angle 3 have to be congruent. Then we come back and we use the transitive property one more time, and we say angle 2 and angle 3 are congruent. Why? Because, again, if angle 2 is congruent to angle 1 and angle 3 is congruent to angle 1, then 2 and 3 have to be congruent to each other by that same reason that we showed that 1 and 2 were congruent, the transitive property of congruence. And if you notice, this last statement here is the proof statement. So this means the proof is finished. So once you get to the last statement, that is the proof statement, and give me a reason for it, your proof is over. And we can logically work our way from this given information all the way through the proof to the concluding statement, which is the proof statement. And these reasons all justify every step of the way. All right, let's take a look at a paragraph proof. This is a different proof. We're going to write the proof a little bit differently. Let me move it up here. So as we look at it, it says angle 1 and angle 3 are supplementary. It says angle 2 and angle 3 are supplementary. Prove that angle 1 and angle 2 are congruent. Okay, so if angle 1 and angle 3 are supplementary, we start off with that information as true. It says, and so this time we're writing it in a paragraph instead of having two columns like we did up here. We're basically just going to say this is true because of this reason. Angle 1 and angle 3 are supplementary because it's given. So there's our statement, there's our reason, just written in a sentence. Okay, and so therefore, if they're supplementary, we know that the measure of angle 1 plus the measure of angle 3 is 180. Keep working. Oh, and that's the definition of supplementary angles. Angle 2 and angle 3 are supplementary because, again, it's given. And so, same reason, measure of angle 2 and 3 are 180 by the same definition. By the transitive property of equality, we can say this is true. Then if we subtract the measure of angle 3 from both sides, that's the subtraction property of equality. And so therefore, angle 1 and angle 2 has to be congruent, and angles with the same measure are congruent. Notice this is not the same statement, by the way. So the measure of angle 1 equals the measure of angle 2, and angles with the same measure are congruent, so therefore our final statement has to be true. So there's a paragraph proof. You might want to look at this one, just sort of pause the video and just read through this yourself and sort of get an understanding of how to write the paragraph proof. And there it is, our notes for section B6.